are we going to talk about today? First, I want to give a brief introduction. Who am I? Who is talking to you today? And then what is the motivation? Why is this topic of securing existing ETCS systems? Why is this relevant for all of you? Then we go through a journey through the V model. Basically, we look at the security life cycle, which activities are done in which phase. And I want to share especially lessons learned and some challenges from the practical work. What was taken care of. And then there should be enough time for your questions. So you can already, during the webinar, you can take notes of your questions if you want, and we will do them at the end. And I'm happy to answer them. So who am I? Who's talking to you? My name is Stefan Karg. My first contact with ETCS I had in 2014, so quite a while ago already. And I would say ETCS is kind of a topic near to my heart, basically, because I'm very interested in the topic of sustainable and green mobility and international mobility. So I love to travel. So this is also a topic I'm personally interested in, basically. So I think we should all work on sustainable ways of having mobility across borders. For that, I think we need to do this in a secure way and in a safe way. So these two topics, security and safety, are very important for me. And I think no one of us can do this alone. So we need to do this in a team. We all have to work together to achieve these goals. You can also connect to me on LinkedIn, or if you want to follow me on Twitter, you find the URLs and the handle, basically. So let's start into why is this relevant for all of us. First, there's the topic of regulation. So in Germany, there is the law is basically called IT Security Act, but there are similar laws in basically most of the countries meanwhile. So you have to the regulatory side, or you have to take into account railways are critical infrastructure. So they fall under these laws. Then we have the standardization. So this gets also more and more evolved. So we now have the TS 5071, which is based on this more generic standard 62443, IAC 62443, which is generally for industrial systems. And TS 5071 is more narrowed down for railway systems, but is based on the 62443. And the third point I want to mention here is that the market situation. If you are in this market, you can have an advantage in the competition if you can announce your system basically as okay. It's especially secure. It has been tested with regard to security. You have an advantage in this market. I think this process, the V model, is known to all of you. Brief introduction into that. So basically, this is the development process which is used for safety critical systems in the railway domain. So we start here on the top left with the concept phase. So this means we start with a concept, then we refine this concept till we at the end implement it into software and hardware until this system is being produced. Then on the upper branch of the V, the system is integrated, tested, validated, and at the end accepted and approved. Then the system goes into operation, and this life cycle does not end, of course, with the operation. The life cycle ends when the system is being decommissioned and taken out of service. So now we look specifically at the security in this process. How do we bring in security in this existing process? I will now briefly go over these points. We will then, in the further slides, we will dig into these topics more deeply. So don't be surprised if now the first glance is quite quick, but we go into each of these bubbles later more in detail. So we start also in the concept phase with the security management plan. Then a security risk analysis is being done. Based on this security risk analysis, based on those results, security requirements are being derived. Those, of course, need to be implemented into the system. There might be also a refinement necessary, so the security design and then the implementation. Of course, no implementation can be proven without doing a proper testing. So we need security testing. And the results of all these activities are being summarized in the security case. So the security case is the formal argumentation. Why is the system secure enough for its intended use? Do we now end with the security lifecycle? No, of course not. Especially for security, this topic of the operation is very relevant. So as you know, the world of security is basically changing daily. So new vulnerabilities might be identified tomorrow. New attack techniques, which we don't even think about today, might be discovered. So we need to stay up to date here. This is why we have this topic of secure operating procedures and looking actually into the system. How secure is it at this day? Railway systems have a very long time they live, years, centuries. So this world out there is changing so quickly that we need to take care that we don't end up with an insecure system at the end. So, and this really also ends with the point of decommissioning. A central tool for that is the security risk analysis. That's why we basically can put it into the center. It's a central tool for doing that. So not only when the system is being designed, this is important, but at all points of this process, basically new knowledge can come up, which leads to the need that a security risk analysis is being updated. So for example, think of the penetration test, so a simulated attack on a system, which shows new vulnerabilities or new paths of an attack which were maybe underestimated in the security risk analysis, which was before done purely on paper, basically. Then it has to be updated. The security risk analysis is, of course, also referenced in the security case. But also during the operation, this is an important tool to decide, for example, how to deal with these newly identified vulnerabilities. So this is the central tool, I would say, the security risk analysis, which also is being used then to take risk-based decisions. So let's dive a bit more into this topic of the security management plan. I first want to briefly motivate this topic. Why is such a plan important directly at the beginning? As you see on this slide, these are basically stakeholders which are already, or might already be in the project, but now have also, an interface basically to security or have something to do with security. For example, take the requirements manager. We will define security requirements in this process. So this means that we have an interface actually to this existing requirements management. So we need to define this interface. There are also new stakeholders, for example, a security authority. Might it be internally in a company or might it be external authorities? We have to deal with them. We have to define how does this cooperation work. So what I brought with me today for you is now an exemplary structure of how such a security management plan or the table of contents basically could look like. First of all, it's important that the normative basis is being mentioned. So ETCS is a European system, so it will be applied in perhaps multiple countries. So if you are a manufacturer of such a system, you usually don't produce it for just one national market, you produce it for multiple markets. So you need to describe actually what is the normative basis of your security work here. And this might really also differ from project to project based on where you are selling your system to or where you are operating your system. Also, you need to reference the company's ISMS, so the Information Security Management System, because this, of course, also lays a base for the secure product at the end. Then usually we show the high-level system architecture, and especially the interfaces. Might be internal or external interfaces, so the technical interfaces are being described. And of course, also the organization in which such a product is being developed or operated is important. So here it's important to describe, okay, how does the current organization look like and which roles and responsibilities are now coming into this organization for the security management. Yeah. We deal with sensitive data in the context of security. These are the last 2 points here, classification and data management, and the communication plan. Yeah. For example, think about the security risk analysis. You basically don't want to find this somewhere out in the internet published because it contains valuable information for an attacker. For example, if there are some not yet mitigated risks in the system, which could be attack paths for an attacker into the system. So you need to define how do you deal with that kind of information, what is sensitive information in the context of security, and how do you handle it. What we as ICS usually do here is already at the very start of our projects, we issue a so-called communication plan. This communication plan basically contains information regarding that. So, for example, how do we transmit confidential information? Is it allowed, for example, to send it only in an encrypted email, or are you allowed to print it out and take it on a business travel with you? And those things are detailed here. Then in the next step, we provide a tabular representation of the security lifecycle. This is then based on the technical standard 5071 on this table 1. There, basically, for each step in the process, we describe what are the deliverables at the end, and what are the deliverables, and what is the input to create these deliverables. What is necessary? What documents are being referred to when creating this input? Then, in the next step, we describe the methodology we use for doing the risk assessment. This is also based on the 5071 and heavily based on the 62443 part 3.2, where this risk assessment workflow is being described. Then, as mentioned before, these interfaces to the stakeholders are really crucial here. For example, do we handle the requirements in the same way as all the other functional requirements, or are there deviations? How to deal with these deviations? How do we talk to suppliers? We might need information from them, for example, as input for our risk assessment. How is this done? What are the interfaces here? Who talks with whom about what? How do we deal with our stakeholders? Then as a next step, you also see basically the V-model in this table of contents. The next step is how do we create a security case, and also who is accepting the security case, or what are the criteria for accepting the security case. And last but not least, also this topic of secure operations. Where is, for example, the vulnerability management being defined? How is this topic of decommissioning be handled? This is also being described already in the security management plan, that this will be taken care of. Now let's go back to the V model. We now talked about this point, the security management plan, and now we'll look more detailed into the security risk analysis. I brought you the structure from the ISC 62443 part 3.2 here. So how does this risk assessment workflow look like? Basically, we start at the beginning with identifying the threats to the system and the vulnerabilities in the system. Then the so-called unmitigated risk is being determined. So this means the risk without any countermeasures in place. Also not those which are already maybe in the system. I will come at the next point to this. So this is just the pure unmitigated risk which is being looked at. So to do this, first the impact is being determined, and then the likelihood, and based on that the risk established. Then in the next step, the security level target is determined. Please note that this is printed in italic letters here. I will come to this point on the next slide a bit more in detail. And then now we take initial or already existing countermeasures into account. Yeah? Since we are talking about existing systems, for example, think about even if there was no specific requirement yet from a security management team to establish a firewall, your development team might have already used the firewall which is there on a platform and configured it in some way. Yeah? So there might be some measures already in place, yeah, which were maybe not formally specified as security measures, but are already in place. So all these measures we can collect now and take into account what is already there. Then we basically re-evaluate the likelihood and the impact, determine the risk, and then we will see, okay, with these existing countermeasures, is the risk above or below the acceptable level of risk? If the risk is still too high, we have to identify, step 10 here, we have to identify additional countermeasures on top of these initial or existing countermeasures. Then we again evaluate if is the risk now below or still above. In case it's still above, more countermeasures, and in case we are below the acceptable risk, we have to, and it's very important, we have to document and communicate results. Let's look briefly into how do we do this at ICS when we do such a risk assessment in the real world. We have basically our own tool developed for doing this risk assessment. We use the attack tree methodology here. So in this tool, we have the possibility to graphically model the attacks on the system. So this also helps, for example, imagine you have a workshop with different stakeholders, so developers, architects, people from RAMs, whatever. Yeah, you can graphically actually look into the system and discuss, for example. And you could also, because the detailed risk evaluation is also in this tool, you could change in this tool, for example, a likelihood and see what are the effects. How does this affect the whole system? So this can be also a great tool for communication actually, and for discussion and for improving the risk assessment. Then a list of countermeasures is being created. They are traceable in a traceable way with IDs. And at the end, the residual risk declaration. As I said, the documentation of these results is very important. So the residual risk has to be documented. Of course, in this step of the process, this is the preliminary residual risk declaration, yeah, because the system is not yet being developed. So the final residual risk is not yet known, for example, because the penetration test is not yet done. Yeah. So this is the preliminary one, but still it's already documented. So I mentioned before the step of determining the security level target. I want to show here best practice how to deal with this topic. So the one challenge is when you determine the security level target and then you look basically in the requirements chapters of the IEC 62443, for example, in part 4.2 down here. For example, part 4.2, if you're talking about components, or part 3.3, if you're talking about the whole system, then you get for this determined security level target, you get requirements. This can be really a high number of requirements which apply to your system then. And in the real world, you might be limited, for example, through these three factors I brought here as an example. So you see here at this pipe, the first limiting factor can be technical challenges. Yeah? So we're talking about existing systems, so you might have a hardware platform, which is an embedded platform, for example, and has already well aged, let's say like that. Yeah? And now, from a security point of view, we would need to bring in, for example, an encryption. Yeah? And perhaps this encryption would not be possible on this kind of processor, because imagine you have even a real-time protocol running there, so your timing would not work anymore. The other challenges here can be monetary reasons, or the time which is in which this project has to be finalized. So basically, what we have to do, our goal is to have the most secure system possible at the end. We have to prioritize. Maybe also lay these countermeasures over multiple releases of the system. So we have to prioritize, where do we start? And here the security risk assessment or the security risk analysis is a very good tool, since we do this analysis in a holistic way. So we do not only take into account, for example, software topics. We also take into account, how is the system physically protected? What are the processes and procedures around it? We look at the system in a holistic way, and this holistic analysis now can help us to take a decision for prioritizing requirements based on the risk. And then we get actually to a subset of these requirements, which have the highest priority to be implemented into the system. Now, after we did the security risk analysis here, we have defined the countermeasures, and these countermeasures have now to be broken down into security requirements. There's actually a second type of element which can be derived from these countermeasures. This is what I want to show you here. The security requirements are those requirements which are directly implemented into your system. So this is what goes basically to your own development. And then there are security-related application conditions, which, like a countermeasure, can also be transferred in a security-related application condition. This means these are things you can, as the supplier or as the integrator, you cannot deal with on your own. This has to be done, for example, by the next level. Imagine you are a supplier and you provide a system. Then how the cabling, for example, is done might be decided by the integrator. And with the security-related application conditions, we can set rules from a security point of view how this cabling should be done in order to achieve the level of risk which is determined in the security risk analysis. This also can be, like, the integrator might also not be the end point for this security-related application conditions. There can also be application conditions which are forwarded then to the operator. Imagine that certain training is being required for someone who operates or maintains the system at the end. So what are some challenges here? As I brought 3 of them. Of course, they are in the more, or you could find more, but I want to put the emphasis on 3 of them now. So as I mentioned before, the existing architecture and platform. We are talking about existing systems. So there is an architecture which was maybe not designed with security in mind, or there are hard or software platforms which are certified, for example, for safety critical applications, where you cannot simply replace library, for example. So in case there's a vulnerability and you need to change this library, you need to recertify, or at least do a Delta certification for this change. So also you cannot just start on the green field and develop an architecture as you would do it today with security having in mind. You have to integrate into the existing architecture. So this can limit your degree of freedom. This goes a little bit into the same direction as the second point here. So we are developing a ETCS system according to a European-wide specification. So, for example, from a security point of view, it would be helpful if the data which is transmitted to the vehicle via Eurobalises would be cryptographically signed, so that we know the operator put this balise onto the track and not some attacker. If we would do this, we would most probably violate the ETCS specification. So we would create basically a system which would not be interoperable anymore, and I mean, this is the goal of the ETCS system, yeah, that we create a system which is interoperable. So this limits us also at certain points and has to be dealt with like not only by the suppliers, but also on the specification level, on the European level, basically. Then the third point I want to shed some light on is the impact on operation and maintenance. The point here is that when introducing countermeasures for security reasons, we always have to have the complete process in mind. So there might be countermeasures where the implementation by the development team is very easy and maybe the security gain is really high. But when the product is out in the field, this might have a huge impact on operation or on the maintenance of the system. So we have to take into account the whole process, not only the manufacturing of the system. Now we have our security requirements, and next step is to implement them. So let's look at what is important here and what are some challenges here. I want to start with a best practice here. So a best practice is actually to create a so-called security design document. This is a document which refines or describes actually how these security requirements are being implemented. Think again of this example of a firewall. So the security requirement might state, okay, please implement a firewall allowing these services. And in the security design document, you would now describe, okay, which firewall am I using? How do I exactly configure it? What are the settings chosen? Why did we choose them like that? This is a document which should be written in close cooperation between the security team and the development team. Why should it be written in this close cooperation? The next 2 points basically feed this decision. Security can make the life of the development team more difficult at the first glance. So for example, we want to switch off certain services which the development team was so far using for example, to open a shell during the development process, and we say, okay, yeah, this is not necessary in the operation system, or it's an unsecure way to do this. We must lock the system down and we want to close this. The development team might not be happy about this. And this is why actually the communication between those two teams is really key. So there should be a close cooperation, and I think creating such a document together and creating a common understanding why certain decisions are being taken or what are the needs of the development team at a certain point and why do they need something like that and why does the security team take certain decisions. This understanding, this common understanding is very important, and creating such a document together can help actually on creating this common view on the system. Next, now we have implemented our requirements. So no requirement is being proven as implemented until it's being tested. So let's look into this part of security testing. And there's again a document to be created at first, this is the so-called security test plan. Basically, this can be also integrated, of course, in the whole system test plan, for example, as a chapter. And what we usually do here is we base these test types on the TS 5071. So I brought 4 of these test types with me for this webinar today. So 2 of them, 2 of these security test types are to be done as early as possible. So for example, if you develop your system in an agile way, this might be done, the requirements-based testing, for example, might be done at the end of the sprint when these requirements are being developed. So you have the chance to find possible flaws in the implementation as soon as possible. Also, this topic of vulnerability scanning can be automated to a certain degree. So you could periodically run such a vulnerability scanner on your system. Then the next 2 types I want to present here, the threat mitigation testing and the penetration test. Those can't be done as early as possible because you need a system which is finalized to a certain degree. a best practice was here for us to do this in parallel to the system test. For the penetration test, I want to go a bit more into the depth. So what is a penetration test here? It's very important actually to have an independent organization doing that. The reason behind that is, or like independent organization really means an organization which was not involved in either developing the system or in doing the risk assessment. So why is this important? The penetration test should actually from the perspective of a potential attacker also identify possible gaps in the risk assessment. So did we forget anything? Did we not think about certain ways to attack a system? Did we underestimate the likelihood or how easy it is to do a certain attack? These things should be identified by a penetration test. And once again, also here, the communication is the key. For example, how do you communicate penetration test findings once you know them as a security team? Here it's important, are you actually blaming your developers in the sense, oh yeah, penetration test found something, you did a bad job? Or do you communicate it in a way that actually we are all together in this, and the goal of this penetration test is not to point fingers on you as the development team, but we all together want to make the system as secure as possible. And this is also very important, to have an eye on that. How are these communicated? How can we resolve that in the best way possible? Now we come to the topic of evidencing that the system is secure enough for the intended use. So here again, I brought an exemplary structure. The structure is based also on the TS 5071. So we again start with the high-level system architecture. As you see in these points, we often work with references here. So we do not repeat the content which is already there in other documents. We reference to the existing architecture document. We reference to the interface documents. Then we provide evidence for fulfilling the security management processes. We reference to the security risk analysis. We reference to the requirement specification, to the security test reports, and the product verification and validation reports. Then we look more into the depth of how these requirements have been fulfilled. Especially we look on if there are deviations. For example, the testing was showing, there are a requirement was not implemented as stated. So these deviations and the influence on the risk of the system have to be discussed here and re-evaluated if it's necessary, or if there are changes in the risk, they have to be re-evaluated. Then usually a system does not consist only of components or software you wrote yourself, but you use third-party libraries, third-party components, subsystems. In best case, they bring actually their own security case with you. Then those are referenced. If they don't bring a security case with them, the security has to be assessed also in this risk analysis before. Best case is if you have such a security case, you can reference to. Then a list of the security-related application conditions is provided, and now in point 9, the residual risk declaration is being provided. So this is now the final residual risk declaration, taking into account the security risk analysis from the beginning, but also all the steps of evidencing how well was the security in reality realized now. This then leads to the so-called security claim. So the security claim at the end states if the system is fit for the intended use, if it's secure enough for this intended use. So as mentioned before, security is not done now. So but we have to now look into how is the system being operated. And we should define rules upfront. One example is why this is so important is the vulnerability management. We should not get into the situation that we define those processes once the first vulnerability appears or once a security incident is reported to us. We should do this upfront. So it has to be clear, how do we deal with vulnerabilities? What are the processes when a vulnerability, for example, in a library is being found? How is it being analyzed? Should be, of course, analyzed with the risk assessment as a tool. Yeah? And then a risk-based decision should be taken how to deal with this vulnerability. Especially in the context of ETCS, we deal with cryptographic keys. So the Euro Radio key management has a life cycle. So keys are being created, keys are being used, keys are being deactivated. So we have to define how to deal with that. Especially here, this point of decommissioning a system is relevant. So is there a mechanism? Is there a process how to get rid of the keys on the devices, for example, before disposing them? This all comes, of course, with this point of roles and responsibilities. Yeah? So, for example, where does an operator call in case they have a security incident? What happens then on side of the operator and on the side of the supplier or integrator if such a security incident happens? Who is doing what? Who is responsible for what? These kind of processes have to be defined upfront, because once you are in this situation, you might not have the necessary time, of course, to allocate resources to define those processes. So to summarize, what did we learn? Or what are 4 main points I want that you take with you from this presentation, from this webinar? The first is communication is key. This is really something which our practical work is showing. The communication is very important, and it's also a very strong tool. So security, as I said in the very beginning, this is nothing one of us can do alone. This has to be a team effort. And the way how we communicate with each other in this journey is very important, yeah, to not lose anyone on the way, basically. We should take decisions risk-based. I was showing the slide with the prioritization. So in the practical work, it is necessary to sometimes take prioritization decisions. But these decisions should all be taken based on the risk. And here, the risk analysis is the central tool to do this. The next 2 points, solution orientation and pragmatism and flexibility, also fall in this category of how does this work in this real world out there. So we have to balance somehow between having security documented and security implemented in the system. We have to take pragmatic decisions sometimes, and because our goal at the end is to have the most secure system possible. So we have to take pragmatic decisions, and we have to orient on the solution we have up at the end out there in the world. So this is now the end of the part where I was talking to you. Now we can start with your questions. So you'll be talking to me now. I have to actually activate your microphone in Teams. So we do it in that way that you have this reactions button in Team where you can lift your hand. So you click on this reactions, and then on the left button there with lift your hand. And if you do that, I will activate your microphone. You still will have to unmute yourself. This is something I cannot do. But once you lift your hand, I will do that. So if you have questions or want to bring in an opinion from your side, feel free to lift your hand now. The first hand I can see, so I will try to. Andy, you can unmute yourself.
Hi, good morning, Stefan.
Good morning, Andy.
Yeah, so Just wondering, are there any lessons learned from integrating the security function along with the safety function, and how those two functional groups communicate, where there are either issues identified on the interface or the components?
So did I get it right? Your question is like how the safety and the security department basically work together on this.
Correct.
Yep. Yes, this is basically. Let me go back to the slide where we see the V model. Then this is maybe the easiest way to explain it. Oh. Just one more slide. Nah. So there we have it. How do they work together? Basically, at the end, the security case, so the security document is also being referenced in the safety case. So there will be actually in the section where this external influences are being evaluated from a safety point of view, the security case will be referenced. Experience also shows, of course, that you should align, or not align, you should always let safety know what you're doing from security side, also in all these steps before that. Yeah? So you should not start talking with each other, of course, here at the end, but you should be in a certain regular communication also on all this process getting to the security case. Yeah? But at the end, the security case is being referenced in the safety case. Does this answer your question, Andy?
It does. Thank you, Stefan. Excellent presentation today. Thank you.
Thank you very much. Okay, are there further questions from your side? Statements, questions? Okay, I see one more lifted hand. Andy?
Yes, me again, Stefan. For people that are new to this, give us an idea of timescales then to go through that V life cycle. Are we talking months or years or decades? Obviously not through to decommissioning, but get to from concept to system acceptance. What's ICS finding for the duration of that?
I would say there's no generic answer on this question. This really depends on the project or the product where you need to integrate this. For example, one question is are you doing this in parallel to a further development of a system, for example, or is the system already out and in use, and you're now asked actually to not change anything function-wise, but only integrate security, which is a challenge, of course. But I would say this hugely depends on this factor. If you have to integrate in another development cycle, or if this is something which you are more free actually to choose, and then of course, it also depends on what kind of system it is. So, for example, if you imagine you have a lot of countermeasures to implement, this also might take much longer than if it's a system which already with this existing countermeasures maybe is quite secure, even without having a formally defined security management before.
Yeah. Okay.
Thank you for the question. Okay. Next hand I see is from Michael Bauer. Let's activate the microphone so you can unmute yourself now. See if it works. My side, I still see that you are muted. Okay. Maybe try again to unmute. Unfortunately, I can't do this. not to work. Continue trying, and we can take, if there are more questions, feel free to raise your hand, and then we can do those first. And okay, I don't see further questions at the moment. So what I want to let's go to one more slide. What I want to share with you as well, actually, as the last takeaway, is actually so our Signal and Draht article. So we published in August an article which goes also into those topics maybe a bit more deeply. So here's the link for you to find this article. You can download it for free. There is also the English version, even though the publication is a German publication, but there's an English version of this article in this publication. So you can find it here on this address. I will once again try. Michael Bauer, you should be able to activate your microphone. Shows me that you could unmute yourself. Looks for me like there are technical problems at the moment. I think you've left at the registration for the webinar. You left your mail address. We will get in touch with you after the webinar. Then we can. Yes. Write me an email and we will get in touch with each other after the webinar. This seems to be a technical problem to activate the microphone. So thank you everyone for your participation. Was very happy that so many of you were joining today, and yeah, have a nice day. Thank you. Bye.